Okay, so we're going to go ahead and start recording. This is Group 1, Chapters 3 presentation. I'm Devin Poe, and I'm here with Eric Pratt and Jeremiah Price, and we're going to tell you a little bit about what was taught in Chapter 3.
Okay, this is Jeremiah Price, and I'll be discussing the first 3 slides. We're going to talk about failure is inherent and how to work safely. Now, a system must be created to catch errors. Usually, in a work environment, especially in development, we're working with complex systems. The characteristics of a complex system defies any single person's ability to see the system as a whole and understand how all the pieces fit together. Meaning not everyone can see how all the parts of the clock work. It's a complex system, and it also means that it's harder for one person to manage or even multiple groups to manage. So we must create 4 conditions in order to make it a safe environment. The first is to manage your complex work. The second is to swarm. Third is to exploit new knowledge. And 4 is to create leaders. Next slide. Now, it's important to see problems as they occur rather than let them slide by and continue on until it's too late to notice them and you have to backtrack your work. The goal is to increase information flow during the work process, and this is done by feedback and feed-forward loops. Feedback and feed-forward loops make a constant flow of information at all stages of development, which makes it easier to catch mistakes, especially with all of the complex parts of the project. The creation of automated systems and tests can help catch errors quickly, usually by debugging or using programs that can catch small little errors within code, and also creating systems that test the code before it moves on to the next stage. Pervasive telemetry. Now, it is defined in the dictionary as the process of recording and transmitting the readings of an instrument. This means for us to see how all the components are functioning. This is essential for complex systems, allowing each person in the project to see how each part works in the complex system. Feedback loops allow us to see not just problems that are occurring currently in the development process, but also allows us to prevent future mistakes from happening. And that's essentially the end goal of all of this, is to create a system to catch mistakes now in the process and prevent future mistakes. Next slide. Now, swarming is one of the methods to catch mistakes and to resolve them as quickly as possible. It is important to diagnose and treat a problem as soon as it arises so we can prevent further damage. Instead of waiting to fix the problem, we have more time, we swarm to fix it immediately. And this involves stopping work temporarily and involving everyone in the project, or specifically in that part of the project, to attend to this error or problem that needs to be fixed. Now you might ask, why? It prevents the problem from progressing, increasing exponentially downstream, so it isn't as expensive to fix. It stops people from starting work which may be flawed. Fixing prevents recurrence of the error. If the problem is not addressed, the problem could recur again, requiring more fixes and work. It is important to promote a workplace environment that encourages individuals to stop production to solve a problem. The practice of swarming helps prevent loss of critical information due to fading memories or changing circumstances, which occurs rapidly. If a lot of time passes since an incident, then it becomes impossible to reconstruct exactly what is going on when the problem occurred. That's why when you catch it in the moment, it's easy for everyone to stop it. And you don't have to recreate the problem. You have the accurate results of the issue because it is in front of you. By ceasing work from everyone so everyone swarms the problem to solve, we prevent further complication factors that might occur if people continue working. So it stops the machine and it allows us to fix one problem so it doesn't create more in the future. And that's all I have.
Okay, and that was Jeremiah. Now we're moving on to Eric.
Yep, this is Eric. I'll be talking more about the benefits of swarming, as well as other things in this presentation. One benefit to swarming is, as Jeremiah mentioned earlier, is to catch things before it causes too much damage. And what we can do what this does is it prevents loss of critical information, increases chances of finding the wrench in the system, and prevents further complications. Next slide.
Okay.
So, in decision making, the person making the decision should be close to the source of the work. So when you're making decisions and the decision making is far away from where the work is performed, it decreases the strength of the feedback between the cause and effect. So one reason for this would be, say a manager needs to make all the decisions, but all the workers in a different facility or a different room experience a problem. They have to wait for the manager to be free or to talk to the manager before the manager makes a decision, then it goes back, and by then a lot of damage could have happened. Say if it's a virus or something has occurred in a database or something that continues causing destruction, the longer you wait, the more destruction it causes. So when you have the decision maker closer to the work environment, it increases strength of feedback between cause and effect, it increases ability to learn from success and failure, and it increases effectivity as there is less of a gap between who should and who is doing something. And it also creates sufficient clarity and timeliness. So some examples of ineffective quality controls would be tasks that can be automated are being done by another team, requiring approvals from people who are distant or busy, like my example of the manager earlier, creating large volumes of documentation of questionable detail that become obsolete shortly after they are written, and pushing large batches of work to teams for approval. So for example, if you have a bunch of tickets that are pushed through, there's a bottleneck of a person or group of people or team or special force that needs to handle all that. Well, if you wait to push that huge batch of information to them for approval, then they have to go through all of that before it pushes back to you, and that causes a bottleneck effect. So these are good examples of ineffective quality controls. So ways to have effective quality controls. So as listed here, the people doing the work should have the power to make decisions to fix problems. Reviews can be done by peers and sharing responsibility for the quality and efficiency of work. For example, reviews being done by peers, this has more to do with the reason why this works with quality control is you have multiple people making decisions about something and you're all on the same page. It kind of goes along with giving power to make decisions by people doing the work. So if you're doing something and you experience a problem, you can feel confident that you can come up with a solution with your peers. Say you come up to a problem that there's a bug in the system that's causing something to be erased. Well, you can quickly make a change in the code that prevents that, and then you can tell your peers, by the way, I caught this is what I did, and then you ask feedback from them to make sure that, oh yeah, that seems good, or they could say, oh, there could be a problem here because of such and such that also occurs. So this is a good example of effective quality controls where you have the freedom to make these decisions, and then of course bigger decisions that require more planning can be done higher up.
Okay, thank you so much, Eric. And so I will be doing the rest of the slides. Now, enabling optimization for downstream work centers. Lean defines the external customer and the internal customer that we designate for. The external customer most likely pays for the service we are delivering, and the internal customer receives and processes the work immediately after us. So that brings up the question, who is the most important customer and why? Well, this is actually kind of a variable answer, but the most important customer is the next customer step in the downstream. So steps must be taken with them in mind to mitigate design problems. Doing this can create quality at the source, resulting in establishing non-functional requirements that we can integrate into every service build. So in conclusion, creating an environment of fast feedback is critical to achieve quality, reliability, and safety in the technology value stream. Solve problems as they occur, enable decisions to be made where the work is, and keep next people downstream in mind when designing processes for them to follow. Sorry.